Okay, let's unpack this. You know how in any field you've got those fundamental principles, the bedrock ideas.
Absolutely. Like uh, laws of physics or even just basic baking rules,
Yeah,
constants.
exactly. The things you rely on. But what happens when you take those foundational ideas
Uh-huh.
and you slam them into a world that's changing at, well, warp speed?
Right. Suddenly you have to look again.
Do the old rules still work? Do they need tweaking?
Yeah, it forces that reassessment, figure out
Yeah.
what's still solid, what needs a bit of an update.
Or maybe what's just completely outmoded now.
Precisely.
And that really gets to the heart of this deep dive. We're zeroing in on principles that are absolutely fundamental in tech.
Software testing principles, specifically.
Core ones. The 7 from the ISTQB, that's the International Software Testing Qualifications Board, for anyone wondering. They've guided QA for years.
They really have ideas that, tons of teams, big and small, have built their whole testing strategies on.
Simple concepts, right? Like you can't test everything.
Or find bugs early. Seems obvious, but
But we're looking at them through a very specific lens, mid-2025.
because the environment now is just radically different.
Totally. I think AI just woven into everything developers do.
Microservices shifting all the time.
Continuous deployment, pushing changes live constantly. It's a different game.
And the source we're using today, it's fascinating. It's a 2025 retrospective looking right at these 7 ISTQB principles.
Asking, okay, how are they actually holding up?
Yeah.
So our mission here is to walk through each one. We'll look at what it originally meant, talk about the specific challenges from, AI, microservices, all that 2025 stuff.
And then, crucially, how teams are adapting.
Right. How are smart teams keeping testing effective now? We want to give you that shortcut to understanding these big shifts impacting software quality.
But you're ready. We're going to look at some classic ideas through a very, very modern lens. High-tech filter indeed.
All right, let's kick off maybe the most quoted one. Testing shows presence of defects, not their absence.
Wow, yes. The classic.
The core idea. Running tests can prove a bug exists.
Definitely. You find it, it's there.
But you can never, ever run enough tests to prove no bugs exist.
There's always that chance something's hiding. It's like the fundamental humility of testing.
It is. A warning against claiming perfection. But our source points out some, well, interesting challenges in 2025.
Like AI-generated tests.
Exactly. That's a big one. You've got these large language models, LLMs, churning out huge numbers of unit tests, integration tests.
And they all pass. All green.
Right. And there's a real danger there. Overconfidence. You see this massive AI-written suite passing, and it feels comprehensive.
It feels like you've got it covered. But that volume...
It can be misleading, can it?
Totally. An AI might generate tests covering syntax, maybe common patterns.
But it could totally miss subtle logic flaws.
Or security holes, things that need a deeper human understanding of what the system's supposed to do or how it could be misused.
Yeah. And then you layer on shift left and continuous deployment.
Oh, yeah. Thousands of automated tests running with every single commit. So if that pipeline's green...
It's so easy for engineers, managers, even product owners to think all green means 0 defects in production.
Which flies right in the face of the principle's warning.
It makes you ask, are we just validating that the tests pass? Or are we really validating the software's quality?
Because passing lots of tests, as the principle reminds us, doesn't guarantee flawlessness.
And another wrinkle, observability. Those sophisticated real-time monitoring tools in production.
They're amazing at catching issues live, sometimes even fixing them automatically.
Which, the source says, can blur the lines. Teams might start seeing observability as testing.
Like, oh, prod will catch it anyway.
But observability is mostly reactive, right?
Absolutely. It tells you what is happening, but it doesn't necessarily validate complex new logic before it hits users.
Doesn't predict those weird emergent behaviors between services.
Exactly. It doesn't replace proactively checking if the fundamentals are correct.
So, adaptations. What are teams doing? The source mentions a shift towards continuous validation.
Right. Seeing observability, chaos engineering, real-time monitoring as partners to testing.
Complements, not replacements.
Yeah. Using those production insights to figure out where to focus testing next.
Not assuming they just eliminate the need for earlier quality checks.
And, this is key, reinforcing exploratory testing.
Yes, and risk-based approaches. Even with AI flooding you with tests, you need humans.
For exploring those high-risk areas, understanding weird edge cases, checking the user experience.
Stuff AI just might not prioritize or even see.
That human critical thinking, the domain knowledge. still essential, especially for complex flows
Yeah.
or subjective quality things.
Which leads nicely into the next one. Exhaustive testing is impossible.
A practical reality check.
Yeah. Software is just too complex. Inputs, states, paths. You cannot test every single combination.
You have to pick and choose. Be strategic.
Yeah. Finite time, finite resources, meeting infinite possibilities.
Yep.
But 2025 throws some curveballs here. Our source mentions, this is cool, early experiments with quantum-inspired testing tools.
Oh, interesting. What do they do?
They promise to suggest test vectors that cover exponentially more state space than classical methods,
Okay.
which could potentially create the impression for some QA leaders that maybe exhaustive testing is possible for, say, small, isolated components.
But that's the trap, isn't it? Exponentially more isn't all.
Exactly. Still not exhaustive. It could create an illusion of completeness.
While missing the really critical paths.
Right. And similarly, AI-driven test generation and mutation analysis tools, they can churn out thousands, maybe millions of variations for one bit of code.
Again, the sheer volume can make it feel exhaustive for that little module.
Even if lots of those tests are, barely different or miss the big conceptual blind spots.
More tests doesn't automatically equal better coverage of relevant risks. You could just be testing the same trivial thing 1,000 ways.
And microservices, that complicates it too.
How so?
Yeah.
You'd think smaller pieces are easier to test exhaustively.
In isolation, maybe some argue you can get close. But the source points out the real complexity explosion happens at the integration level.
How all those little pieces talk to each other dynamically.
That's where the combinatorial nightmare lives, so the principle still holds for the whole system's behavior.
Got it. So how do teams adapt?
The source suggests shifting focus to purposeful coverage.
Okay, what does that mean?
It means even with tools that can generate tons of tests, the challenge isn't making tests anymore. It's strategically choosing the ones that matter most.
Focusing on risk, even when you could drown in variations.
Moving the emphasis from volume to ensuring the tests you run are targeted and give valuable feedback for your system and its risks.
Makes sense. Quality over quantity.
And another key adaptation, investing in provenance and traceability.
So knowing why a test exists.
Exactly. Don't just accept a test suite because an AI spat it out. Understand why specific tests were created.
Trace them back to requirements, risks, user flows.
Right. It gives you accountability. Ensures tests are tied to meaningful goals, not just algorithms.
Knowing the why helps you trust the test's value, especially with so much automation.
Okay, let's talk principle number 3, early testing.
Yeah, the classic wisdom. Find defects early.
Because fixing them later gets exponentially more expensive, right?
Nip it in the bud before it grows legs.
Think requirements, design, code reviews. The earlier, the better. But this principle bumps up against some modern workflows.
Like model-driven development or low-code, no-code.
Exactly. Those platforms are huge now. Big chunks of code get auto-generated from visual models or configs.
And testing often becomes a post-generation thing.
Yeah, that's what the source observes. We'll test the code after the platform spits it out.
Which kind of compresses or skips the stages where you normally plan tests based on requirements or design.
The speed bypasses the intent of early testing, which was about spotting issues before code even exists.
Testing auto-generated code quickly isn't the same as planning for testability during design.
Good point. And what about AI helping with requirements analysis?
You mean LLMs reading user stories and suggesting tests?
Yeah, sounds like testing happening early, right?
Potentially. But the source warns about humans becoming overly reliant.
Assuming the AI has got it covered.
Right. Deferring their own critical thinking about test strategy, about blind spots.
Because an AI analyzes text patterns, it doesn't necessarily have the deep domain knowledge.
Or the critical eye to ask probing questions about ambiguities, or missing non-functional requirements, or weird edge cases a human expert might see immediately.
Plus, CI/CD pipelines. They're often set up on day 0. Testable code exists almost instantly.
Which feels early.
But teams might still delay writing those comprehensive, human-driven acceptance criteria or exploratory test plans until the code's merged and running somewhere.
So the technical opportunity for early testing is there.
But the crucial test thinking about value in complex scenarios might still lag behind the code creation itself.
Interesting point. So adaptations.
Embed test thinking right into requirements and design reviews, even if code generation is fast.
Humans need dedicated time up front.
Yeah. Testers need to review initial concepts, designs, check for testability, potential problems, what coverage is needed before implementation locks things in.
Get testers involved when the what and how are being decided. Their perspective is invaluable.
And crucially, pair AI-generated plans with human validation.
Don't just take the AI's output as gospel.
Right. If an AI proposes a test plan, it's a starting point, a draft.
Domain experts have to review it, add to it, validate it, check for things AI might miss, like subtle security issues or complex interactions.
The AI is a powerful assistant for volume and ideas.
But human oversight ensures the strategy is smart, comprehensive, and actually tackles real-world risks.
Okay, moving to Principle 4, defect clustering.
The Pareto principle for bugs, 80-20 rule.
Basically, yeah. About 80% of defects tend to hang out in about 20% of the modules.
So the advice is, focus your testing effort there, on those historically troublesome spots.
Direct your limited resources where they're most likely to find issues. Makes sense.
But 2025 makes this complicated.
How so?
Ephemeral microservices, distributed ownership.
Okay, unpack that.
In a dynamic microservices world, services are constantly changing. Updated, refactored, replaced, even spun up and down on demand.
So a component that was a bug magnet last month?
Might not even exist next month, or its function moved. Historical bug data for a specific module gets stale fast.
The traditional module as a stable thing for clustering? It's kind of disappearing.
Bugs aren't staying put in predictable places.
And with cross-functional teams owning features end-to-end.
Features that cut across multiple services.
Defects tend to pop up at the interaction points, where different services, data stores, third-party APIs meet in complex ways.
Right. Not neatly located inside one buggy module anymore.
The hotspots are those dynamic connections between services, much harder to track with old defect history.
Plus, integrating third-party AI components. Black boxes.
You use an AI service, but you can't see inside it or test its internals.
So defects cluster around your integration points with it.
Or they appear unpredictably when the vendor updates their model, and it has nothing to do with your code changing.
You're testing how your system reacts, but the source of the potential problem is hidden and outside your control.
So adaptation strategies. The source talks about adopting real-time risk predictors.
Instead of just old bug data for modules.
Right. Leverage live telemetry, error rates, performance metrics, user feedback across services in near real time.
To see where this system is showing stress or failing right now.
Use that observability data to find the current hotspots in production or staging.
And focus testing and monitoring there at this moment.
And also, test at the business transaction level.
Shift focus away from individual services.
Towards validating critical end-to-end user journeys, or data flows that span multiple microservices.
Because defects often cluster in those crucial paths that deliver user value.
Regardless of which underlying service is actually hiccuping.
So you align testing with user impact and business outcomes. A more stable target for finding those clusters than constantly shifting services.
Okay, Principle 5. The pesticide paradox.
Run the same tests over and over.
They get less effective at finding new bugs.
Like pests building resistance. Software builds resistance to static tests.
So you need to update existing tests or write new ones to keep finding new problems. Keep the suite evolving.
Makes sense. But the challenges in 2025, especially with automation everywhere, they're interesting.
Like auto-updating test suites via AI.
Yeah, some advanced pipelines use AI to analyze code changes, user behavior, production incidents.
And automatically tweak or regenerate test cases.
Right. And some teams might think, great, the AI handles the updates. We don't need to worry about the paradox manually.
But is the AI truly targeting new risks?
Or just creating variations on existing themes? Is there a risk of trusting a self-evolving suite too much?
Without human oversight to make sure it's not just reinforcing old coverage while missing whole new types of problems.
Absolutely. And this also connects to a test case explosion.
The sheer volume generated by AI.
Thousands, maybe millions of test cases weekly. Some are useful, sure.
But many might be near duplicates, low-value variations.
This massive volume makes it really hard for humans to manage. It dilutes focus.
Increases the signal-to-noise ratio. Harder to spot real failures in a sea of irrelevant ones.
Exactly. You end up with this huge suite, expensive to run and maintain, and it's tough to tell if a failure is a real bug or just noise from a bad test.
Plus the reliance on shift-right, production observability.
Some teams might deprioritize maintaining their traditional test suites in staging or pre-prod.
Yeah, thinking production monitoring, feature flags, chaos experiments will catch everything important anyway.
But prod monitoring focuses mainly on overall health, right? High-level errors.
It might miss subtle functional regressions or edge case bugs that only show up under specific test data conditions.
Things that aren't easily replicated or seen in live production flows.
So, adaptations to counter the pesticide paradox now. Introduce human in the loop for test evolution.
Okay, so if AI suggests updates or new tests,
Have a human tester or domain expert review them.
assess the value, weed out redundancy.
Ensure the changes align with the current strategy and known risks.
The AI suggests, the human curates.
Keeps the suite focused, relevant, valuable, without unnecessary bloat.
Makes sense, yeah.
Prioritize high-value test maintenance. Actively prune stale or redundant tests.
Don't just let the suite grow unchecked.
Focus maintenance on tests covering critical business features, security, compliance.
Code paths that change a lot or have a history of issues.
Quality over quantity. A smaller, well-maintained suite targeting key areas is way more effective than a huge, unmanageable one.
Definitely.
Principle 6. Testing is context-dependent.
No single best way to test.
Right. The approach depends heavily on the project's context.
Tech stack, domain like healthcare versus gaming.
Risk level, team structure, development method, all of it matters.
You tailor your strategy to that specific project.
But this bumps up against the modern push for standardization. Template-driven tools.
You mean those domain-agnostic tool chains?
Yeah, platforms that promise to auto-detect your system and generate tests or configs from generic templates.
Convenient, but
The source notes, it can lead testers to rely on defaults and neglect crucial domain-specific details.
like compliance rules in finance, safety certs for medical devices, specific privacy needs.
Stuff generic templates might completely miss.
Absolutely. And what about hybrid human AI teams? They're common now.
AI as a co-programmer or co-tester.
But the AI's training data might be generic. Open source code, public docs.
Not reflecting your team's specific context. Internal standards, custom protocols, legacy integrations.
Right. And testers might just blindly trust the AI's suggestions, missing issues only relevant in their specific environment.
The AI doesn't automatically get your company's unique setup, its history, its tech debt.
Its suggestions need that contextual evaluation.
Plus, rapid deployment means continuous shifting contexts.
Oh yeah. A single feature release might go through dozens of environments.
Local dev, shared dev, staging, pre-prod, canary, shadow prod, phased rollout, full production.
And each one is slightly different. Configs, data sensitivity, scale, traffic patterns.
Treating testing the same across all those ignores crucial differences.
The risks and the right tests can vary significantly between them. Testing with prod data in staging is different from synthetic data in dev.
For sure. So how do teams keep context awareness? The source suggests formalizing a context matrix.
Okay, like documenting the specifics for each one.
Yeah. For each component, service, deployment environment. List its tech stack, compliance needs, data sensitivity, expected usage, specific risks.
And use that matrix to define tailored testing approaches for each unique context.
Exactly. Make the dependencies and constraints explicit. Helps ensure generic tools get applied appropriately.
Smart. And for the AI.
Train AI models on project-specific corpora.
Fine-tune the AI.
Yeah. On your internal docs, architecture diagrams, historical bug databases, domain jargon. Make the AI understand your context.
Not just the general programming world.
The more it understands your system, its history, its domain.
The better its suggestions and analysis will be. A more informed co-pilot.
Okay, finally, Principle 7, absence of errors fallacy.
Just because you found few or no bugs.
Doesn't mean the software is actually good or meets user needs.
A technically perfect piece of software could still be useless or unusable or just the wrong feature.
Functional correctness isn't the same as value or usability.
And this one feels perhaps the most challenged today.
How so?
Feature flood. Green build syndrome.
Pressure to ship dozens of features super fast.
Often, if the automated pipeline turns green, the feature gets toggled on in production.
Without maybe robust review of user feedback or actual value.
But the product can get bloated, confusing, even if each bit is technically defect-free.
The focus on speed and technical checks overshadows the big question. Is this actually solving a user problem? Delivering value?
The test gates aren't measuring success in those terms.
Another example the source uses. AI-driven UX personalization.
AI tailoring interfaces or flows for users.
QA might test that these personalized flows no technical errors.
But are they checking if the personalized experience is actually better Makes sense. Introduces bias.
Right. An error-free AI flow could still confuse people, frustrate them, or even subtly discriminate.
The defect isn't a crash. It's a failure in UX or an unintentional negative outcome. Traditional metrics miss that.
And integrating things like generative AI for recommendations or risk scoring.
That introduces business logic and ethical gaps.
Your test might verify the system doesn't crash calling the AI.
But are you testing the quality of the recommendations? Their fairness, alignment with regulations, ethics?
Error-free could mean it's functional, but producing biased output or violating privacy.
Pushes testing into totally new areas, needing different skills, different evaluation criteria, focused on outputs and real-world impact.
Not just internal technical correctness.
Exactly.
So the adaptations are about broadening the definition of quality. Institute value-centered testing gates.
Beyond just technical defects.
Add checkpoints focused on KPIs that measure value and user success.
Like user engagement, task completion rates, accessibility scores.
Even metrics for AI output fairness, if that applies. Expand what done means at your release gates.
It's not just passing tests. It's demonstrating likely value and avoiding negative impacts.
And, crucially, gather early user feedback, even with all the automation.
Use dark launches, feature flags.
Expose new stuff to small user segments first. Collect real-time usage data and feedback.
To validate if it's actually working for real users before a full rollout.
Because real-world interaction is the ultimate test of value. You need users to confirm it actually solves a problem.
Wow. Okay. So we've gone through all 7 core ISTQB principles.
Testing shows defects. Exhaustive is impossible. Early testing, defect clustering, pesticide paradox, context-dependent, absence of errors fallacy.
And really seeing how this mid-2025 landscape, AI, microservices, CI/CD, is challenging and reshaping them.
It's clear, isn't it? The fundamental wisdom holds up.
But the practical application needs serious adaptation. You can't just apply them the old way.
Absolutely. And looking back at the source's overall take, some big themes emerge.
Like balancing AI and automation's power with human judgment. That critical thinking piece.
Yeah, that's huge. And shifting from just static or historical data
to leveraging real-time risk intelligence from production, from user interaction.
Using observability as a partner to testing, definitely not a replacement.
And prioritizing value and impact over just test volume or defect counts.
And maintaining that context awareness, even when systems are fragmented and changing fast, making sure testing is relevant.
All pointing towards measuring success differently.
Not just by bugs found or not found, but by actual business outcomes, user satisfaction.
Understanding these challenges, these adaptations, it's absolutely key for effective QA today, whether you're building software or just using it.
These shifts are really redefining what high-quality software means now.
It's a different world.
So here's a final thought then. If the goal isn't just 0 bugs anymore, and value is measured so differently, does that mean the very purpose of testing itself is subtly, but maybe profoundly changing?
That's a really interesting question to ponder.
Something to keep thinking about. Thanks for joining this deep dive.